Alright, welcome to my first video algebra lesson. Let's see how this works. So today we're going to be talking about section 8.7. There we go. 8.7, which is functions defined by equations. Now, what you should do before you watch the rest of this video is hit pause right now and turn to page 379 in your textbook and read through that page of writing there, and also look at examples 1 and 2. That way when you start listening to my lesson, you'll have more background knowledge, and hopefully I can answer the questions that are coming into your head as you look at some of these examples. The first thing you might notice is something called arrow notation. Okay, and what arrow notation is, well, let me give you an example. So we have f colon x arrow 3x minus 2. Okay, so you might be looking at that thinking, what the heck is this? I have no idea what's going on. It's actually just a fancy way of writing y equals 3x minus 2. So that f colon x, or f of x, which we'll talk about more later, is just a way of representing y. Okay, so you'll also see this notation under it. So it might say d equals -7, 0, and 5. Okay, so the d represents something called a domain. So d stands for domain, and then later on we're going to use something called r, and that stands for range. Domain and range. Okay, domain is just a fancy word for the x values, and the range is a fancy term for the y values. So to give you an example of that, let's assume I had a jar of quarters. Okay, so I have a jar of quarters. Okay, and the amount of money I have, we'll call it m equals amount of money in the jar, and let's say q equals the number of quarters in the jar. So I could set up an equation. I could say, well, the amount of money I have in my jar is equal to 25 times the amount of quarters. So in that case, the money would be in cents, right? If I put 0.25, then that would be the amount of money in dollars. So right here we have the money equals 25 times the number of quarters in my jar. Now if I wanted to talk about the domain of this equation, notice I write x values and y values. Well, in this case, q is where the x would be, right, and m is where the y would be. Q, the domain would be, how many quarters could I have in my jar? So the domain in this case would be whole numbers. I could have 0 quarters in my jar. I could have 1 quarter, or 2 quarter, or 2 quarters, or 100 quarters even. Okay, but what I cannot have in the jar is a half a quarter, or 1/4 of a quarter, or 0.7 quarters in the jar. That just wouldn't make any sense. So the domain in this case domain would be whole numbers. Now, if you wanted to get picky, you could say, well, there's got to be some maximum amount of quarters that would fit in the jar. But for now, we can just say the domain would be whole numbers. Now, the range in this case is represented by M, or the amount of money I have. So the range could include, it could be 0, because if I have 0 quarters in the jar, I could have 0 money. But it could also be all multiples of 25. So if I had 1 quarter, I could have 25 cents. If I had 2 quarters, I would have 50 cents, and so on. Okay, so this is a real-world situation, and when you talk about domain and range in the real world, you have to be a little more specific. Okay, when you're talking about just any equation in math that doesn't have any real-world words associated with it, so if I came up with this equation, y equals 2x. In this case, the domain can be anything. The domain, the x value could be negative 100. The x value could be 0. It could be 2.7. It could be 3/5. Because there's no words associated with it and we don't know what x stands for, it can be anything. Okay. Because of that, the range can also be anything. Okay, so the domain and range in a regular equation would be different than the domain and range in a word problem. Okay, so getting back to arrow notation, so we're looking at this original arrow notation here. Let me see if I can copy this over to the next page. Let's try it like this. Nope. Okay, so here's that arrow notation that I showed originally, and we had the D, which is domain, and it was -7, 0, and 5. Okay, so I might ask you, find the range. And the notation makes it look very complicated, but this is actually a simple problem that you've done, you know, in probably 7th grade and 6th grade. It's just with different notation. So essentially what this means is y equals 3x minus 2, and you're just going to plug in values of -7, 0, and 5 for x. Okay, so you could set it up like this. You could set up like an XY chart. Okay. So if we plug in -7 from the domain listed earlier, then we would plug in -7 here. And we could do this mentally. -7 times 3 is -21. -2 would be -23. And then we plug in 0. And 3 times 0 is 0. -2 is -2. And now we can plug in 5. So 3 times 5 minus 2. So 15 minus 2 would be 13. Okay, so it looks complicated with the arrow notation and all that, but it really means y equals 3x minus 2, and you just plug in these domain values and you get your y values, which is the range. So the range is -23 negative 2, and 13. And that's your answer.